shall be looking at the concept of physics practical. Oh, sorry, I'm trying to set my camera right. Okay. Okay, guys, you're welcome to this channel. So we're going to be preparing for physics practical as far as 2022 WAEC is concerned. Are we together now? So in this class, we shall be looking at every concept of physics that has to do with the forthcoming the forthcoming theory and objective. Yeah, so for today's class, what we are going to be covering is going to be basically 4 topics. And those 4 topics, we shall be explaining them in line with what WAEC is expected of those topics. That is, the objective of WAEC on that topic is what we are going to be considering. It's not as if we are going to be taking it like we are taking our regular classes. Are you getting this now? Let me move closer so that I can actually read you guys' comments. Thank you so much. You're welcome. So kindly share this post so that people can actually join us here so that we can all learn together. And I believe after this class, you will be very glad that you are here, and your preparation towards the forthcoming exam is going to be of a tangible one, and you can easily tell to yourself that it's as if you are prepared already. Okay, without wasting much of our time, so that we can shift to action very fast, is that we are going to start by looking at the topics from the foundation. By His grace, from now till Monday, we are all going to be meeting on live session like this. I will always announce the time to you guys so that you can come online, ask your questions, get prepared, and I pray you will all pass by His grace. And I'm very sure you must have get your practical done very well. Those that did alternative A and alternative B, and for those that actually reach out to me, can you hear me, guys? Please, if you can hear me, say yes, please. If you can hear me, say yes. For those that did A and alternative B, I believe the practical video really assists our process. Sure, because I saw those questions and I know it definitely does. For those that reach out to me, those alternative B, and I took my time to talk to them, and I believe they did well in the exam. So let's also do the same thing for theory and objective. Are you getting it now? So without any further ado, we are starting the class right away. I promise you guys chemistry practical video by His grace. I've spoken to a friend of mine and is going to be producing the video for us. I can also subscribe to his channel. He is also a YouTuber. Chemistry Hangouts. Yeah, you can search for it. He has enough content for you guys in chemistry. There's nobody that says you need to pay for runs or assistance before you can dust your exams. No, you don't need those things. All you just need is preparation. And remember, you are meant to understand all these things. Don't know it. Because even me myself, I don't know physics. But what? I understand it. So I want you to also do what? Understand it. And our first topic today is going to be the very basic topic. And that is fundamental and derived quantities. So the topic we are going to be looking at is fundamental and derived quantity. Yeah. So now when you talk about fundamental and derived quantity, what do we mean by fundamental quantities and derived quantity? Well, it's guys, hope my screen is not mirrored. Please check. Hope the screen is not mirrored. Okay. Now when you talk about fundamental and derived quantities, what examiner wants to know about this topic? Examiner wants to know if you can differentiate between fundamental and derived. That is, do you actually know quantities that are fundamental? Are you getting this now? And do you actually know quantities that are derived? These are questions that examiner wants to know. Are you getting this now? More so, they want to know, can you actually establish relationship between a fundamental quantity and a derived quantity? Those are the three things that they want to know basically on this topic. And I will quickly brush through it before we move to the next topic. And if you understand, just let me know in the comment section. Please share this video, like the video. The more you share the video, the more people get to know about it. And the more you drop your comment, the more YouTube will keep notifying people so that they can join us and they can benefit from the class. Okay, guys. Now, when you talk about fundamental quantity, what fundamental quantity simply means is that quantity that you cannot express in terms of another quantity. That is, you can't express them in terms of another quantity. For example, you all agree with me that velocity is expressed in terms of what? Distance, and time. Are you getting this now? Velocity is expressed in terms of distance and time, and that is why the unit for velocity is meter per seconds. So, it's expressed within what? Two quantities. But if it is a fundamental quantity, you can't express it in terms of another quantity. It's impossible. Are you getting this now? But because velocity is a derived quantity, that is why you can express it in terms of another quantity, and that is distance and time. Am I making sense now? So this is a derived, but fundamental, you can't express them in terms of another quantity. For example, if I say time, you can never see time expressed as maybe kilogram and something, meter and something. No, it's absolutely what? So direct as what? Seconds. Are you getting this now? Because it is a fundamental. The same thing goes to length. If you look at length also, you can't express it in terms of another quantity. You can only express it in one way, and that is what? Meter. Now, let me quickly clear you about this. You might be saying, but this man said we cannot express length in terms of another quantity. What about kilometer? Are you getting this now? What about miles? What about centimeter? What about millimeter? No, those are metrics. Are you getting this now? Those are what? Metrics. They are not quantity. Is that taken now? But when you look at meter and you look at seconds, they are standing for a quantity. Am I making sense now? So please take note of that. I'm back to this place now. So length now, you can't express it in terms of another quantity other than itself. The same thing goes to, what is it called? Mass. Mass, you can't express it in terms of another quantity than what? Kilogram. Are you getting it now? Remember, you can also express it as what? As in tons, or you express it as a gram. Am I making sense now? That does not mean that you are expressing it in terms of another quantity. Just like what I explained earlier, you are expressing it in terms of metrics. Are you getting that now? Sorry, please. Okay, so we have mass, we have time, we have length. We have temperature. We have current. We have luminous intensity. And we have amounts of substance. Are you getting this, guys? Okay, so if you look at this now, you have mass, time, length, temperature, current, luminous intensity, and the amount of substance. All of these, they are fundamental. Are you getting this now? And what makes them fundamental? Correct. You cannot express them in terms of another quantity. Am I making sense now? That is what makes them fundamental. Another name given to a fundamental quantity is that what? They are the based quantities. They are what? The based quantity. That is, quantities that form the basis of measurement. Quantities that form the basis of measurement. They are what we refer to as what? Fundamental quantities. Am I making sense now? Okay, guys, if that should be the case, let's move on now. We have understand what fundamental quantity is and we know their example now, isn't it? Now, what about derived quantities? Derived quantities are those quantities that are formed by the combination of two or more fundamental quantities. That is, when you combine two or more fundamental quantities, the quantity they are going to form is what we refer to as a derived quantity. Those quantities, they need to be expressed in terms of another quantity. Am I making sense now? But before I go into that, I quickly want to point out something that examiners usually do. And I want you to be aware of it so that you don't fall victim. What is that? You know, we said we have 7 fundamental quantities here, isn't it? But if examiner want to ask you a question, they will say, state the 3 fundamental quantities in science. So when they ask you to state 3 fundamental quantities in science, you'll be asking yourself, but we have what? We have 7. Why 3? Which one should I state? It's fine. Don't stress yourself. In science, we have what? 3 fundamental quantities. And I will tell you why they are just 3 instead of the 7. Now, they are 3 because they are the most basic quantity. That is, quantity that contributes to virtually every aspect of science. Are you getting it now? Unlike every other 4. Those 3 quantities, they contribute to every aspect of science. And those 3 quantities include what? The mass, time, and length. Are you getting this now? Mass, time, and length. And that is why you will see in exams, examiner will always be asking you to find the dimension of a quantity in terms of what? MLT. Why? Because they agree that what? Mass, length, and time are the fundamental quantities in science. Are we making sense, guys? Okay, if that should be the case, let's move on now to derived quantity. Like I defined earlier, they are quantities that form the basis of measurement. Sorry, that's for fundamental. Derived, they are quantities that are formed by the combination of 2 or more fundamental quantities. Am I making sense now? Okay, what are those quantities? You will agree with me that when something is fake, sorry guys, I didn't mean those quantities as are fake, but just want us to relate with what is happening around us. When something is fake, it tends to be cheaper and it tends to be in large quantity, that you are going to have them to be much. So the same thing goes to derived quantity. Unlike the fundamental quantities that we just have 7, are you getting this now? Derived quantity are more. Are you getting this now? We can't count them all, but we should just know them. The very common ones include velocity, force, acceleration, momentum, work done, okay, which other one? Power, torque, or you call it moment. Now, these are derived quantities. Now, I want to show us something. That is why I listed these ones as our examples. The reason is because WAEC is so fond of using or asking you to find the dimension of all these quantities. Are we together now? And that's why they are the one I cited as the examples of derived quantity. Are we together now? Correct. So if that should be the case, these are derived quantity. What are the things that you need to always watch out for when it comes to derived quantity? You always need to understand their relationship between fundamental quantities. That is the relationship that exists between that quantity and what? Fundamental quantities. Once you understand the relationship that occur or that is between that derived quantity and fundamental quantity, then you are good to go in answering questions that has to do with dimension of a physical quantity. I know many of us, we are still having issue with dimension of a physical quantity, but no problem. We are all going to what? Trash it in this class. Okay, now watch something. Watch something. I want you to note distance, displacement. These two quantities, as they are like this, they are fundamental. Are we together now? They are what? Fundamental. And what makes them fundamental is the fact that they are length-related quantity. Are you getting this now? They are length-related quantity. You cannot express them in terms of another quantity. That's why we regard them as what? Fundamental quantity also. Am I making sense now? But instead of you mentioning distance, displacement, just call it what? Length. Anything length related is fundamental. For example, height, altitude is said to be what? Fundamental. Am I making sense now? Okay. Now, the difference between distance and displacement, we all know that, of which we are still going to talk about that as we move on in today's class. And that is one is a vector and the other is a scalar. Are we together? Am I making sense, guys? Okay, if that should be the case, let's quickly move on. Now, when you are given a question that has to do with a quantity, the question you should always ask yourself before you attempt that question is that, what is the unit of this particular quantity? Because if you are given a quantity and you don't express that quantity in terms of its units, you tend to get it wrong. I repeat, you tend to get it wrong. And even though when you do the right thing, you still arrive at the wrong result because you don't follow the appropriate unit. And what's the appropriate unit for velocity? Velocity is what? Meter per second. Force is a kilogram meter per second square. Are we together now? Then acceleration is meter per second square. Momentum is a kilogram meter per second. Then work done is kilogram meter square per second square. Power, kilogram meter square per second cube. Then torque, kilogram meter square per second square. Now guys, I know you are going to be surprised that it's not like that. Normally, the unit for force is supposed to be Newton. The unit of what's it called? Momentum is supposed to be Newton seconds. The unit of work done is supposed to be joules. Then power is supposed to be watts. Then torque is supposed to be what? Newton meter. Okay, it's fine. Let me clear your doubts now. These are the actual units of all these quantities. But in honor of the scientists that work on those quantities, that give us the appropriate meaning and measure of those quantities, they're not like, okay, let their unit equivalence to the name of that scientist. Am I making sense now? So, for force, because Sir Isaac Newton was the one that actually worked on force to give us the actual definition of force and the meaning of force and how to measure force. So, we said in honor of him, anything that has to do with force, let's measure it in his name. And that is why kilogram meter per second square is equivalent to Newton. Am I making sense now? And then for work, the scientists that works on it very well give us the measure, give us the appropriate meaning of it, is what we refer to as what? Joules. And that is why kilogram meter square per second square is equivalent to what? Joules. Am I making sense now? Then for power, the scientist that works on it that give us the appropriate measure of it is what we refer to as what? Watt. So, and that is why kilogram meter square per second cube is equivalent to watts. Are you getting it now? Then for torque is Newton seconds. Why? Because it is force times perpendicular distance. Distance is measured, Newton meter, that's what I mean. This is not seconds. It is momentum that is Newton seconds, yeah. Because it has to do with force multiplied by what? Time. Are you getting this? So that's why it's what? That's why it's Newton seconds. And then for torque, it is what? Newton meter, because it's force multiplied by what? Distance. Am I making sense now? Correct. So all of these are the units of all these derived quantity. So when you are given a question and that question is not in these units, am I making sense now? It is your right to convert it back to that particular and appropriate units. I believe I'm clear now. Fine. The next thing we want to look at now is now derived, how to come about derive the formula. That is the dimension of a physical quantity. So how do we come about that? Okay. So, welcome back, guys. We all understand that if WAEC is asking us about fundamental quantity and derived quantity, we can all answer questions as regard that now, because we already know examples of fundamental quantities, we know examples of derived quantity. Now we want to know the next thing that examiner might be of interest when it comes to this topic, and that is the concept of dimension. You hardly scale through it. It's always in your first section. Are you getting it now? So how do we look for dimension of a quantity? It's very simple, guys. Let's look at it. When you talk about dimension, the first thing you should understand is that what is the meaning of dimension of a physical quantity? Dimension of a physical quantity simply means establishing a relationship or proving the relationship that exists between a fundamental quantity and a derived quantity. And the reason is because once a quantity is said to be a quantity, if that quantity does not have relationship with the fundamental quantities, then the quantity does not exist. Are you getting it now? Once that quantity does not have relationship with the fundamental quantity, then the quantity does not exist. In order to prove the existence of the quantity, that is why they always ask us to look for dimension formula of a certain derived quantity. If you are going to be an engineering student here, I would like you to master this aspect of physics very well, because it's going to help you a lot in fluid mechanics. Are you getting this now? Because in fluid mechanics, you tend to generate more of equation yourself. Am I making sense now? And that will only be possible when you can go about dimension of physical quantities. Am I making sense now? Please, guys, don't forget to always share this video as we are online now. Share it, so that more people can join us. And don't forget to like if you are yes to like. Let's go on, guys. Now, when you want to find the dimension of a quantity, what are the things you should know? I'm going to take us through step-by-step approach on how to come about a derived, dimension of a physical quantity. Now look up. Whenever you see anything that has to do with mass, under dimension, it is stated to be capital letter M. Am I making sense now? And anytime you see anything length related, under dimension, it is capital letter L. And when you see anything time related, under dimension, it is capital letter T. These are the foundation. Am I making sense now? These are the foundation. But other than these ones, there are other ones also, as temperature, temperature is either you use what? Theta to represent that of temperature, or you use capital letter K. Okay, it seems somebody has a question here. Okay, somebody is asking that we should assist with what is it called? Sound wave calculation. Don't worry, we are going to take care of all the topics. Mind you, this class is going to be coming up from now till Sunday or Monday. Are you getting this now? I probably not do anything on Monday or maybe Monday evening. Okay, please, somebody, can you just let me know when you're having physics? Please, somebody should drop it in the comment section so that I get to know when you'll be having physics, please. Okay, so I will definitely trash all those topics that I feel is going to be a difficult thing for you guys. So relax. Are you getting this now? We're going to trash all aspects of wave completely, right from what is wave down to the aspect of sound wave and sound instruments. Everything shall be covered by His grace. Am I making sense now? Let's go on. So this is for temperature. Am I making sense now? Then for currents, I have the ampere, but we denote it with what? Capital I. Then we have the next one, which is a luminous intensity, and that is what? J. Are you getting this now? And the amount of substance is capital N. Have you seen this now? So these are the symbols that we use in dimension of a physical quantity. Am I making sense now? Correct. So mass is capital M, length is capital L, time is capital T, temperature theta or K, current I, luminous intensity J, then amount of substance is what? Capital N. These are the things that we use for substitution under derive or dimension of a physical quantity. Am I making sense now? Now, what are the steps to take in order for you to have your accurate mark as far as WAEC is concerned? Okay, 15th of June, that's on Wednesday. Alright, it's fine. We should be able to cover it before or not before then, by His grace. Let's just keep in touch and always turn on your notification bell so that you always get notified when we are live like this, so that you can ask your questions and get everything about sound wave done. Are you getting it? Or any other topics that you might be finding difficult. Because in today's class, we're going to be covering like 4 topics. And so it is tomorrow and Sunday till we are going to have the exam. So let's see how far we can go with it. Is that taking up? Okay, let's back to class, guys. Okay? So here are things that you're going to be using for substitution whenever you are dealing with what? Dimension of a physical quantity. You what? You substitute with mass, you substitute with length, you substitute with time, you substitute with what? Temperature or Kelvin. But I don't want you to focus more on this now. Why? Because you deal with this most when you are in the university already. Are you getting this now? But for this basic level, we focus more on these 3. Am I making sense now? So how do you now answer question under dimension of a physical quantity, and you have your accurate mark as stipulated in what? WAEC marking guide. These are the steps. They are 4 steps that you need to take when you are doing dimension of a physical quantity. How many steps do I say? 4. Now, step 1. Step 1 is to know the formula of the quantity. The formula of the quantity. That's the first step. For example, if I say find the dimension of, let's say, velocity. If I say find the dimension of velocity, the first thing you want to know is the formula for velocity. Then step 2, express the formula as a fundamental quantities. Express the formula as a fundamental quantity. Are you getting this now? Step 3, Step 3, substitute the fundamental quantities with their symbols. You know what I mean by their symbols here? That is capital M for mass, capital T for time, capital L for what? Length. Then, lastly, express your results as exponential. Do you get this now? I will quickly recap it now for those who are not, for those that are yet to put it down. Number 1, you write down the formula of the quantity. Number 2, you express the whole formula as a fundamental quantities. Number 3, you substitute those fundamental quantities with their symbols. Number 4, you express your answer as an exponential. What I mean by exponential is that you express it in an index form. Are you getting this now? So that is the steps that you need to take in order for you to have your accurate mark when you are dealing with what? Dimension of physical quantity. Am I making sense now? So let's take a look at an example on that. Okay, example on that. Examples. Find the dimension formula. Find the dimension formula of velocity. Let's start from simple to complex. We are asked to look for the dimension formula of velocity. How do we obtain the dimension formula for velocity? So we start. Step 1, you are not to write step 1, no. But for you to understand, that is why I'm taking it like this. Step 1, you ask yourself, what is the formula for velocity? Displacement over time. That's the formula for velocity. Displacement over time. So, the second step, that is step 2, is to express everything you are seeing here as a fundamental. We don't really recognize displacement as a fundamental, even if it is a fundamental, right? So, we replace it to become what? Length over what? Over time. Everything you are seeing here now is a fundamental, because length is a fundamental and also time is a fundamental. So step 3 is to do what? Is to substitute for all this fundamental quantity. And for length, we use capital L to substitute for length, divided by time. We use capital T to substitute for what? Time. Are you getting it now? At this point, this is our step 3. Then, step 4 is for you to express L over T in an exponential form. Am I making sense now? Therefore, this will become LT raised to power minus 1. So, the dimension formula for velocity is what? LT raised to power minus 1. Am I making sense? Okay, let's look at another quantity now. Another quantity. Let's look at force, for instance. Okay, let's take acceleration. Let's take acceleration. Acceleration. We want to obtain the dimension formula for acceleration. How do we go about that? The first step is to do what? To write down the formula. Step 1, acceleration is equal to velocity all over time. Are you getting this now? Velocity over time. That is acceleration. Cool. Now, step 2, velocity is not a fundamental quantity, isn't it? It's a derived. So we need to break it down to become a fundamental so that everything we are going to be seeing will be a fundamental quantity. So velocity is the same thing as saying what? displacement, which we can write as what? Length over time. Are you seeing it now? Multiply by 1 over time. For you to understand what I did here, I split this to become velocity times 1 over time. Are you seeing it now? And velocity is what? Length over time, then multiply by 1 over time. That's what we have here. Are you getting this now? So if this should be the case, and we have that what? Length all over what? Time squared. Can you see that now? I'm doing all of this for you to understand. Are you getting it now? Normally, what I'm supposed to do is just to say, this is going to be L over T squared. Simple. Do you get that now? So, acceleration is now length over T squared. You can see, everything I'm seeing here now is a fundamental quantity. Length is fundamental, time is also what? Fundamental. If that should be the case, acceleration is now equal to capital L all over capital T squared. Have you seen that now? So if that should be the case, acceleration is going to be what? LT raised to power minus 2. And that is the dimension formula for acceleration. Are we getting this, guys? Now, I will now take us to the next one now, which is force. Are you getting this now? Force. Dimension formula for force. What is the dimension formula for force? Let's quickly get that done. Dimension formula for force is just what? What I'm going to do now is that I'm going to solve this one just like what you should do in your WAEC question. Since you've understand the explanation now, Abi. Now let's take for instance that we are both students now, and we are given this question. How are we expected to solve it? Now let's see. This is force, so I'll just write down that F is equal to what? Mass times acceleration. You can see. Then second step is that I'm going to break this acceleration down to what? To its own formula, because acceleration is derived. And step 2 is for me to show that everything there is a fundamental quantity. So I'll have that mass multiplied by acceleration. Acceleration is velocity over time. Abi? Fine. Velocity is still what? A derived quantity. So I'm still in step 3. So I'll have that F is what? M multiplied by 1 over T, then multiplied by V, which is L over T. Are you seeing this now? And this is equivalent to ML over what? T squared. Are you seeing this now? So we can now go to what? The third step. So we have that F equal capital M, capital L over capital T squared. Then step 4, which is going to be our result, that is ML T raised to power minus 2. Now, let me quickly tell you something. WAEC can be a bit tricky. Instead of them to ask you that, find the dimension of this, they can say, obtain the unit for this quantity. Am I making sense now? They can say what? Obtain the unit for this quantity. If they put that question like that, they are still asking you for the dimension formula. But what you are going to do is that once you get to this step 2, am I making sense now? So step 3, instead of you substituting with what? Capital M, capital L, capital T, you will now substitute with their units. Are you getting this now? That is, this will now become kilogram, this one will become what? Meter, divided by this one will become what? Second squared. Have you seen it now? That is what it's going to be if the question is put to you like that. And then your result will now be kilogram, meter, seconds raised to power minus 2. Have you seen the way we obtain the, what is it called now? Where we obtain the units now. So you just have to understand. Once you understand, then you have no issue with it. You blast your WAEC, you blast it, guys. Can we go on? So let's take a look at 2 or 3 more examples on that dimension. Then we'll move to the next topic. Okay? So let us obtain dimension for momentum. We want to obtain dimension for what? Momentum. So momentum The symbol for momentum is P. Are you getting it now? Is what? P. So equal to mass multiplied by velocity. That is the formula for momentum. Mass times velocity. Okay, so momentum is therefore equal to mass multiplied by length over time. So everything here now is what? Is a fundamental quantity now. Mass is fundamental, length is fundamental, time is also fundamental. So if that should be the case, momentum will become capital M times capital L over capital T. So we have substitute, right? So momentum will now become ml t raised to power minus 1. And that is the dimension formula for momentum. Okay, so the next one now is the dimension formula for work done. Because they seem to perceive work done and power to be difficult. Are you getting this now? I'll do work done and gravitational constants now. Then you can now go home or go back to your past questions, check like 20 years back. Are you getting this now? And start looking for questions that has to do with dimensions. Then you are able to, you should be able to solve them and see what your results will be. Is that taken now? That is how we learn. Thank you guys. Okay. Now, the next one we want to do right now is what? The next one we want to do now is work done. Now, for work done, we have the formula for work done to be force times distance. Force times distance. But if you are writing in WAEC, guys, you write your distance as S. Since the symbol for distance is what? S. So you write it as what? S. Then we have that work done is going to be your force is going to be mass times acceleration. Abi? So it's going to be mass times acceleration times distance. Are you getting this now? So work done is equal to mass multiplied by acceleration is now what? Distance over time squared. Remember, I've shown you before. I think we understand how we come about this. Because acceleration is velocity over time. Abi? And velocity itself is what? Distance over time times 1 over time. This distance is displacement, but anyone just call it distance for this case. Are you getting it now? So when these multiply themselves, you have distance over what? T squared, which is what I have here. Am I making sense? Correct. So carry on, multiply by what? Distance now. So work done is therefore equal mass times distance squared all over what? T squared. So we now need to, okay, let me write this one as length squared. Yeah. ml squared all over what? T squared. Am I making sense now? So we substitute with the symbol. That will be capital M, capital L squared all over capital T squared. So work done is therefore equal to ml squared t raised to power minus 2. Can you see this now? So that is the dimension formula for work done. Now, if they don't want to ask you for work done, examiner can ask you for moments, or they ask you for torque. Are you getting this now? It is still the same thing. Why? Moment is the product of force and perpendicular distance. And mind you, there is no difference between perpendicular distance and ordinary distance. Why we say perpendicular distance is to make moments to be a vector quantity so that we can tell them that work done is a scalar. But in actual sense, those two quantities are the same. Only that one is having direction, the other one is not having. So the one that is having, we call its own distance to be perpendicular. But you still arrive at the same derived units. Am I making sense now? Okay. So, if I clean up this, that's to tell you that if the question says find the what? Torque, the dimension formula for torque, or find the dimension formula for what? Moment, I will still do the same thing. I'll just tell them moment is equal to force multiplied by perpendicular distance. This symbol shows what? Perpendicular. Am I making sense now? So it doesn't affect S still remain what? S. Then you go on with what we just finished doing now and you arrive at your results. Do you get that cleared now? Fine. So now let's move on to the next one, and that might be the last one we are going to consider, and that is gravitational constant. How to find the dimension of gravitational constant. How do we get that? If I have that dimension for gravitational constant, I'll recall that gravitational force is F equal what? G m square all over r square. In this case, you don't make the mistake of saying F is equal to gm1 m2 over r square. Otherwise, you will complicate your issue. So what you just think is that just assume that this is mass, they are the same thing, and just write it as well. F equal gm square over r square. Do you get that clear now? So if that should be the case, you therefore have F to equal, okay, let's make G the subject of the formula from here, Abi. So in order for us to do that, we cross multiply. We have F multiplied by r square, gm square. So G now becomes fr square over m square. Remember, the arrow there is what? Distance. Are you getting this now? So where you have to take note of that. Where r is what? Is distance. Do you know the essence of all this? The essence of you noting that r is a distance is because when you are solving WAEC question, you need to let them understand that you know what you are doing. And if anybody pick up the book, even if the person does not understand physics, they can easily read what you've done and they will understand that, yes, this is the reason why you do this. Is that taken out? Okay, so if that should be the case now, we can now what? Go on. Because this is not the formula for G. We can now go on from here to find what? The dimension formula. Abi? So, and how do we do that? We just write down what? G equal, our force is what? Mass times acceleration, then multiply by the length square all over the mass square. Are you seeing this now? So that this mass can take care of one of this. You know, this is mass times mass. So one mass we cancel one. So it will remain just what? One. Am I making sense now? So this one will now become acceleration multiplied by length square over m. Are you seeing it now? So acceleration is what? So G equal acceleration. Let me move to this side. So G will become acceleration, which is a length over time square multiplied by length square all over mass. Are you seeing that now? So G now equal L cube all over mt square. So you've successfully expressed everything as a fundamental. The next thing you want to do is to substitute. So we substitute and say capital L cube over capital M, then capital T square. Are you seeing that now? So G now equal L cube m raised to power minus 1, t raised to power minus 2. Have you seen that now? So, and this is just the dimension for gravitational field. But don't leave your answer like this. Are you getting this now? Why? Because your answer is always in form of MLT. So you need to rearrange this one. So that it's going to be in what? MLT. Are you getting this now? So how do we go about that? We just write that G equal m raised to power minus 1, l raised to power 3, and t raised to power minus 2. And that is how you get your dimension for gravitational constant. Another quantity that WAEC like using is surface tension. Are you getting this now? Surface tension. And what is surface tension? Force per unit length. Force per unit length. So just try as much as you can to master more quantity in physics and know their formula. Once you know their formula, you are good to go. Do you understand that now? Now, let me now give you a quick way. That is another way in which WAEC used to ask questions under this particular dimension of a physical quantity. The other way they can ask you question under this is that I can tell you that what value of x, y, and z will make m raised to power x, l raised to power y, and t raised to power z be false. They can choose to use false, they can choose any other quantity. But the question will always come in form of m raised to power x, l raised to power y, t raised to power z. At times they can ask you, they can say, what value of x, y, z will make m raised to power x, l raised to power y, t raised to power z equal Charles' law, or equal Boyle's law, or equal pressure law? Are you getting it now? Just know those things that they want it to be. So if they say, what will make this to be false? All I just need to do is to go and find the dimension of force. Am I making sense now? So I'll now say force is mass times acceleration, Abi, and then that will be mass times L over T squared, Abi, and this will be what? LL over T raised to power 2, Abi. So F, which is what? Force, is now equal capital M, capital L, then capital T raised to power what? Minus 2. You know, this is the dimension for force, Abi. So you're not going to take this dimension and equate it with what is given to you. That is m to power of x, l to power of y, t to power of z equal f. And m, l, t raised to power minus 2 also equal what? F. So the two can be equal. So if you equate the two, when you equate the two, you have what? M to x, l to y, and t to z to equal m, l, t to what? Minus 2. So if you compare coefficients, you get to see that this is m to x equal m to 1. M and m will do what? Cancel. Then x equal 1. You do the same thing with what? With L to y. And that will still be L to y. L to y equal L to 1. So this and this also cancel. You have that y is what? 1. Then you pick the last one. T to z equal t to minus 2. This and this cancel. Then you have that z equal minus 2. Therefore, the value of x, y, and z equal 1, 1 minus 2. And that's that. Then you solve the question. That's the peak they can go. Is that taken now? Fine. So, a quick recap. When we start the class, we are able to define what? Fundamental and derived quantity. And we stated examples of fundamental and example of what? Derived. And we said fundamental quantities include mass, time, length, amount of substance, current, temperature, and luminous intensity. Then we said derived quantity, they are much in number, such as velocity, acceleration, force, momentum, work, force, any other thing. They are all derived. Abi? And from there, we are able to look at the units of derived quantity. And we said whenever we are given a calculation to do, we should always make sure that we convert to the appropriate unit. And then we look at dimension formula. We look at those things that we use to substitute for what? Fundamental quantities, where we are dealing with dimension of a physical quantity, such as what? Capital M for mass, capital L for length, capital T for time, capital K for temperature or theta, then J for luminous intensity, then we have capital I for current and capital N for amount of substance. Am I making sense now? So those are the substitution symbols for all those fundamental quantities. And then we mention 4 steps that you need to take in order for you to answer your questions under dimension of a physical quantity appropriately and get your answer completely. And what was that? We said first step, you need to know the formula. Second step, express the whole quantity as a fundamental. Third step, input those symbols for it, substitute the symbol for fundamental quantities for them. Then lastly, express your answer as an exponential. And then we'll look at examples on it. So that marks the end of that topic as far as WAEC is concerned. Now, we are going to move to the next topic, which is vector and scalar. Vector and scalar quantity. Now, when you talk about vector and scalar quantity, let me bring this one since we're done with it. Yeah. Okay, cool. Now, I want you to take all of these things down and let's brush it as far as possible. What examiner want to test us on as far as vector and scalar is concerned? Number one, they want to know if we actually understand the meaning of vector and scalar. Number two, they want to know if we can actually identify quantities that are vectors and the ones that are scalar. And they want to know if we can calculate for the resultant in any way they give it to us. Those are the things that they want to test as far as vector and scalar is concerned. So how do we go about that? It's very simple, guys. And we can do it. Definitely, we can do it. Now, let's do it. Yeah, let's do it. What is a vector quantity and what is a scalar? If I ask you that, how old are you? You don't need to waste much of your time, and I don't need further question. Are you getting this now? When you tell me your age, that you are 16 years old. So, saying that you are 16 years old, I don't need further information again about your age. Are you getting this now? In one word, I understand the question. What does that mean? That means that your age is a scalar. Because quantity that you can describe in one word, they are referred to as a scalar quantity. I can ask you, how many cups of tea can you finish? You tell me 4, 5, 15, 16. In one word, I understand the numbers of cups of tea you can finish. That is a scalar. Are you getting this now? And because those questions, they only required magnitude. Are you getting this now? Those questions only required magnitude. That is why you can only answer them in one word. Therefore, when we say a scalar quantity, we say quantities that has only magnitude but no direction. I'll take it again. A scalar quantity is a quantity that has only magnitude but no direction. And what do I mean? Examples of scalar quantity include. Now, listen to something. Some of us might find it difficult that what is called magnitude. What is magnitude? It's cool, it's fine. What is magnitude? Magnitude simply means size. Are you getting this now? Magnitude means what? Size, amounts. That's what we refer to as magnitude. So, example of scalar quantity includes what? Distance. Are you seeing this now? Distance is a scalar quantity. Work done. You have to master this because in your textbook, there is not always sufficient examples of all these things. Because of time, let me just be dictating them so you take them down. 1, distance. Work done. Power. Are we there? Power, I want to say first before, but first is not there. Area, pressure, volume, efficiency, mechanical advantage, excuse me, mechanical advantage, velocity ratio, resistance, reactance, inductance, capacitor, capacitance. They are all examples of a scalar. Are you getting it now? They are examples of a scalar quantity, including strain, density. Are you getting it now? All of those ones are scalar quantity. Another hint, all fundamental quantities, they are scalar. All fundamental quantities are scalar quantity. Is that taken now? Fine. Can we move on? Yes. The next one is a vector quantity. For example, when somebody slap you, that is, the word slap is related to cheek, right? But now, let's say somebody hits you, because when you say somebody slap you, I already know where it is. It means in your ear. Fine. But let's take, for instance, that somebody hits you outside, and you want to go and report inside. Then you get to meet your mom or your dad inside, and you say, oh, Jide hit me. Especially if you are a female. The first question they want to ask you is that, where does he hit you? Is he on your head? Because, especially Yorubas, I don't know what's special about this edge that they will be like, they don't touch, you can beat my daughter in anywhere you like, but you cannot touch her head. Or you can beat my son anywhere you like, you cannot touch, you must not beat him on his head or something like that. I don't know what's special about the head that you cannot flog when it's not correct. Okay, guys? So they will always want to know where the person actually hits you. And that's why, the reason why they want to know is because they are here to get the full detail of what happens to you. And what makes it like that is because hitting you is a force. And a force is a vector quantity. It requires magnitude and direction. So when you describe a force with only magnitude, are you getting this now? It's never going to be complete. Nobody will ever going to understand until you include direction. So all quantities that you cannot describe with only magnitude, are you getting this now? Those quantities are referred to as a vector quantities. And that is why we define vector quantities as quantity that has both magnitude and direction. I'll take it again. Quantities that has both magnitude and direction. They are what we refer to as a vector quantity. Yeah. Do we get that now? Now, what are now the examples of vector quantity? I'll also state like 10 for you, just like I did for the scalar, so that you can have enough examples at hand. Number one, for vector quantity, we have displacement, we have velocity, we have acceleration, we have force, we have momentum. Are we there? We have momentum, we have stress. How many have I mentioned? I don't even know, but I think I've mentioned up to 6, right? Okay, let's take more. We have current density, we have magnetic flux density, we have field intensity. And this field intensity can be gravitational field, electric field, or magnetic field. Are you getting this now? They are all vector field. We have temperature gradient, is also an example of a vector quantity. So you need to master all these examples. Are you getting this now? Now, somebody would like to ask me this question that, sir, how can we determine that this quantity is a vector or scalar? It's very simple. You can know if a quantity is a vector or scalar in 3 ways. If one way fails to work, the other will work. If the other one fails to work, then the other one will work. But the most simple and the easiest way to know if a quantity is a vector or scalar is by what the textbook categorized or what your teacher showed you in the class. Am I making sense now? I believe no teacher will want to teach rubbish. So they will tell you what it is. Just like I stated all of these ones for you now, you know that they are vector. And you know the ones that are scalar. That is why the most easiest way for you to identify vector from scalar is by what you read or what you are being told. Then, the second way of you knowing if a quantity is a vector or scalar is by definition. For example, if I say energy, what is energy? Energy is the ability to do work. Energy is the ability to do work. The word ability is the only thing that describes energy for you, right? An ability has to do with only magnitude. And that is why anything called energy, being it what? Kinetic, being it potential, being it chemical energy, being it mechanical energy, any form of energy, I get even nuclear energy, any form of energy that you might have, they are all scalar. And anything energy related, such as power, work done, they are also scalar. You can see we get to know that it is a scalar from what? From the definition. Likewise, if I say force, for example, if I say what? Force. What is force? Force is an external agency. Where, the first thing they first of all tell you there is what? Where it's coming from. They are telling you its direction. An external agency that changes or tends to change the position of an object. You can see from that definition, it's obvious that what? A force is a vector quantity, because the first thing mentioned in its definition is direction. Am I making sense now? Okay, so those are ways that you can use to know that this quantity is a vector or it is a scalar. Another way of knowing that a quantity is a vector or scalar is by their mathematical relation. For example, if I have something like pressure, pressure is given as force over area. Are you seeing this now? Force over area. And then stress is also given as what? Force over area. But this one is a scalar and this one is a vector. Am I making sense now? Now watch. This one is depending on area. This one is depending on what? Area. That is, you can use area to describe pressure. And how do you use area to describe pressure? You all go to church on Sunday. If you don't go to church on Sunday, you all walk around the street and you see people going to church, isn't it? Fine. Now, let's take a look at those beautiful girls that always want to go to church and oppress the poor ones. They put on high heel when they are going to church, right? Putting on high heel with a tiny sole will never make them walk fast. That will delay their movement. Are you getting this now? They tend to move slow and slow. Why are they moving slow? It is because the area of their shoe that is in contact with the ground is small. And the smaller the area, the higher the pressure required. Are you getting this now? So they are exerting more pressure in order for them to gain stability. That is why they are walking slow. Are you getting it now? Tiny sole, it covers small area. Small area results to what? High pressure. But what about those poor girls or those ones that never cares of high heel? They are not the fan of high heel. They put on flat sole while going to church. That flat sole tends to cover more areas. The flat sole cover what? More areas, and therefore it requires less amount of pressure, because the bigger the area, the smaller the pressure. Are you getting this now? You can see that pressure is being determined with what? Area. So since pressure is depending on area, that simply means that if area is a scalar, then pressure would also be what? Scalar. And area is a scalar, therefore pressure is also a scalar. Do we get that now? Fine. Then if you look at stress, it is the ratio. Are you getting this now? Stress is, okay, let me put it like this so that I'm not going to try to explain more things. When you say stress has to do with an elastic material. Ability for a material to elast. Are you getting this now? And for a material to elast, you need to apply force. Are you getting this now? the more force you apply to a material, the more the material what? Extend. Are you getting that now? So this one is depending on force. And force is a vector quantity, therefore stress is also a vector. Do we understand that now? So those are the ways we can know vector quantity other than a scalar quantity. Am I making sense? If you are getting it, let me know in the comment section. Okay, so now that we've understand what is a vector and what a scalar simply means now, I believe we can now move on to the next stage of this class. And what is that? We want to talk about addition and subtraction of vector. Okay, if you are getting what I'm explaining since, please let me know in the comment section, please. Like if you understand the class from beginning down to this time, let me know in the comment section, please. Okay? I'm here to see our comments. Okay? Let's move on while we await our response to that. Now, when you talk about direction, direction has to do with a vector. A scalar has nothing to do with direction. Therefore, when we talk about addition and subtraction of a scalar quantity, it is done with simple algebraic. There's no need for any grammar or something. Are you getting this now? It can be done with simple algebraic. But when it comes to vector, you can't do it with simple algebraic. Why? You need to put into consideration the direction. Am I making sense now? To subtract or to add a vector, you need to understand their direction. Am I making sense now? So let's quickly look into that. Addition and the subtraction of addition or subtraction of vectors. Yeah, since we are already dealing with vectors, you know we are talking about the addition and subtraction of it. Is that taken now? Now, you are going to add two vectors or more together when they are facing the same direction. So, if I have vector A and I have vector B facing the same direction, you can see that the arrow, they points to the same direction. Abi? So, it means you are going to add them together. So, A plus B, they will give us a result called what? C. Now, this C is called resultant of A and B. They can just say, find the resultant of A and B. And since A and B are facing the same direction, their resultant is going to be what? Their summation. Get this clear, right? Correct. If that should be the case, what if they are facing opposite direction? If I have that, this is A, and I have that, this is what? B. If I'm looking for the resultant of A and B, then the resultant will be A minus B, and that will be what? C. Are you getting this now? Now, I want you to get something clear here before we go on. Hello, please, if you are getting what I'm explaining, please just comment yes in the comment section. Let me know, so that we know we are together, please. Is that taken out? Okay. A minus B equal what? C. Isn't it? Now, this is because A and B are not facing the same direction. But there is question that they always want to ask here, that you yourself always want to be cleared about. And that is it going to be A minus B or B minus A? The question is, anyone with the highest value. Are you getting this now? So you take the small one away from it. For example, if A is greater than B, then your result will be A minus B. If B is greater than A, then your result will be what? B minus A. And that's why when you read some mathematics textbooks, you get to see that they'll just put this as an absolute value, A minus B equal C. That is how it should be written in a textbook. Telling you that either A is greater than B or B is greater than A. Pick the absolute value. Are you getting this now? That is, if I have that 3 minus 5, are you seeing this now? You know, the result is going to be minus 2. So, because it's minus 2, don't worry. Pick absolute value. Absolute value of minus 2 is 2. Do you understand that now? So, that is how to go about the, what's it called? Remind me. Addition and subtraction of vector. But this is quite simple, isn't it? It is. But let's make it a bit complex. Let's make it a bit complex. If I have a point here and I have a point here and here is another point, then let me connect them like this. So this is point A, this is B, and I have this like this. So this is C. Can you see the board? This is what? A, B, C. Now tell me which of them are in the same direction as C. That is between A and B. Which one are in the same direction? And which one is in the same direction with C? Yeah. Between A and B, which one is in the same direction with C? Look at the board very well, please. So let me know your comment in the let me know your answer in the comment section, please. I'm waiting. Which one is in the same direction, please? That is between A and B. Which one is in the same direction as C? That is the one that is in the same direction with C. Which one? Any response? The essence of this live class is so that we can interact together. You can ask a question and I can respond. Otherwise, recording the video and uploading it is fine. So, if you are there, please comment below. Just let me know your opinion, then we'll move on. Excuse me, please. Okay, no response. Okay, it's fine. Let's move on. Since nobody is online to respond. Now, if this is A and this is B, for you to know the one that will be in the same direction with C or any other ones, you have to understand the fact that for every vector, there's always 2 reference points. And those 2 reference points are named as initial points and terminal points. I see this now. Initial points and terminal points. How do you know initial points from terminal points? Initial point is wherever the arrow is backing. And where the arrow pointed towards is going to be your terminal point. Are you getting this now? Initial point is where the arrow is backing, and terminal point is where the arrow is heading to. Am I making sense now? So if that should be the case, our initial point is this, and this is our terminal point. So coming to this diagram, you get to see that the terminal point of A is this point here. Abi? And here happens to be its initial point. And the terminal point of B happens to be this point. Here happens to be the initial point of B. The terminal point of C is this point, and here happens to be the initial point of C. Now, for you to know if they are in the same direction, then terminal point of one must equal to the initial point of the other. I will take it again. Terminal point of one must equal to the initial point of the other. Are we making sense now? Okay, if that should be the case now, let's look at this diagram now. If you look at this diagram, you will see that terminal point of A, remember, when they are in the same direction, they share the same terminal point, when they are in the same direction, they share different terminal points. That is, terminal point of one will be the initial point of the other. When they are facing what? Up the same direction, terminal point of one will be the initial point of the other. But if they are facing opposite direction, then terminal point of one will be the terminal point of the other one too. Or initial point of one will be the initial point of the other. In statement, we said two vectors or more are said to be in the same direction when their terminal point and initial point coincides. That is, terminal point of one coincides with the initial point of the other. But they will be facing opposite direction when terminal point of one coincides with terminal point of the other, or initial point of one coincides with the initial point of the other. Are you getting that now? So looking at this diagram now, this is terminal point of A, and it happens to be the initial point of what? B. That shows that A and B, they are facing the same direction. And if you look at A and C, the initial point of A is the initial point of what? C. That's to tell you that what? A and C, they are facing opposite direction. Are you getting that now? Also, if you look at C and B, they share the same terminal point. That's to tell you that that's to tell you that C and B, they are not facing the same direction. Is that it now? So like the question I asked earlier, that's to tell you that neither A nor B are in the same direction as what? C. Am I making sense now? So this particular diagram, that is this diagram you are seeing here, this is C, this is A, and this is B. This particular diagram, you can write it as A plus B equals C. Are you seeing this now? So, because A and B are facing the same direction. Do we understand that now? Okay, please, if you understand, let me know in the comments so that we can move on. That is the essence of the live class, so that we can interact with each other and respond to our question as fast as possible. Is that taken out? Okay, let's move on. So we're talking about what? We are able to explain the concept of addition and subtraction of a vector. So the next thing we want to look at right now is to know what is called, what we refer to as, what is it called? Resultant and equilibrant. Resultant and equilibrant. Resultant and equilibrant. Now, when we talk about resultants and equilibrants, when we talk about resultant and equilibrants, we need to understand these two distinctly. What is called the resultant? Resultant is a single vector that will have the same effect as two or more vectors acting at a point. I'll take it again. Resultant is a single vector that will have the same effect as two or more vectors acting at a point. Likewise, equilibrant. Equilibrant is a single vector that will balance the system of two or more vectors acting at a point. Okay, let's take it one after the other now. Let's start with resultant. Now, how do we calculate for resultant? We have understand the definition now. A single vector that will have the same effect as two or more vectors acting at a point. Let me quickly give us an instance. When we say resultant, in your class, you have a class captain. If the teacher wants to see the whole of the class, by default, the entire class, are you getting this now? you are going to be more than your teacher's office, isn't it? Fine. In that case, instead of the teacher to call the old student, the teacher will call the class captain. In that case, the class captain before the teacher is like the whole of the class. Therefore, you say your class captain is a resultant to the class because he's acting as the class and is a single person. Like now, I'm currently in Nigeria now. The ambassador of Nigeria in US is a resultant to Nigeria in that place. The ambassador of Nigeria in Ghana is a resultant to Nigeria in Ghana. Whatever he says, it's like the whole Nigeria says it. I guess it's having the same effect as the whole Nigeria. The same thing goes to what? Resultant. When resultants, a single vector, is having the effect of two or more vectors acting at a point, that's what we call resultant. Now, these resultants you might be required to look for it in different ways. Number one, when vectors are just moving either parallel to each other, either they are facing the same direction or not. Number two, if they are perpendicular to each other. Number three, if they are more than two. Number four, if they are inclined at an angle that is not 90 degrees. Can you see? So let's trash all of that. We've trashed the first one. That is, maybe they are parallel to each other. Are you getting it now? Or they are moving and the angle between them is either 180 or 0. In that case, we treat them as addition and subtraction. But in the case whereby they are perpendicular, how do we treat them? We need to understand that. In the case whereby they are more than 2, how do we treat them? We need to understand that. In the case whereby they are inclined at an angle that is not 90 degrees, we need to understand that. So now let's look into that now. The first one is when they are perpendicular. How to find the resultant of two perpendicular vectors. So given two vectors A and B that are perpendicular to each other. So this is vector A and this is what? Vector B. They are perpendicular. When two vectors are perpendicular, it means the angle between them is 90 degrees. So the resultant of this vector is this. Are you seeing this now? And this is the angle of projection. Are you seeing this now? So this one comes back like this. If I call this point O, and let me call this point A and call this point B. Let me change this one to become U and this to be V. Am I making sense? And these two vectors U and V are perpendicular to each other. Is that taken off? So if that should be the case, look up now. I'm having two right angle triangle here. Let me call this point C. A right angle triangle OCB and a right angle triangle OAB. Are you seeing it now? So you can consider any of the two triangles. So this angle is alternate to this angle here. Can you see? Okay. So if that should be the case, I can consider any of the two triangles like I said. I'll say consider right angle triangle OAB. So right angle triangle OAB is this. So can you see this now? And here is angle theta. So this is R, and this is V, and this is U. Can you see now? And this is OAB. Correct. Now, in the question, you are already given what? U and V. That they are perpendicular. So you already know the value of U and V. You are only looking for the value of their resultant, which is what? R. And how do you find that? Since this is a right angle triangle, we just use Pythagoras Theorem. So when two vectors are perpendicular, you use Pythagoras Theorem to find their resultant. So we have R squared equal U squared plus V squared. So R equals the square root of U squared plus V squared. Have you seen that now? So this is a resultant. But what if we are looking for the direction? Because resultant is also a vector. And you can't just find the magnitude and say it is up. No, you need to find the direction also. So how then can you find the direction? The direction is the value of theta. So just determine the dimension, that is the value of theta. Once you can get the value of theta, then that's the value for the direction. And how do we go that? We just say the tangent of theta, that is tangent theta. Okay, let me move up for the beats. So we have tangent theta equal to our opposite over adjacent. This is opposite and this is adjacent. Abi? So you have that theta is arctan of V over U. Are you getting this now? So let's take for instance that V over U now give us a result like, let's say 40 degree. So let's say we have that V over U. When we take the arctan of V over U, our result is something like 40 degree. Then how do we write down our direction? So assume that theta is 40 degree. So if theta happens to be 40 degree, what you just need to do is to say what? Is to say, draw your cardinal point like this. You know, this is north, this is south, east, and west. Abi? So 40 degree should range somewhere here. Are you getting this now? So if it is like this, then you can write that what? The direction is north 40 degree east. Do you get that now? So that's how to determine the direction when the vectors are just what? 2 and they are perpendicular. Now, what if the vectors are not perpendicular? That is, they are more than 2. It's fine. When the vectors are more than 2 vectors, there is a way we can also find their resultant. But before then, we need to understand what they call resolution of a vector. What is resolution of a vector? Resolution of a vector is the breaking down of a given vector into its component. The breaking down of a given vector into its component. How do we mean? If I have a vector like this is vector R, and it makes an angle theta with the horizontal. This vector R that you are seeing is having a support along the horizontal axis, and at the same time is having a support along the vertical axis. Are you getting this now? So the support along the vertical axis, let's write it as R sub y. And the support along the horizontal axis, let's write it as R sub x. Now, if they now ask me to resolute vector R, that means I have to break R into components. Am I making sense now? And for me to be able to do that, what I just need to do is to find the value of this R sub x and find the value of R sub y. So, since I know theta and I know the vector that I want to find its component, I can just use what? The sine, the SOHCAHTOA. Are you getting this now? So, that will become trigonometry ratio. That will be sine theta equal opposite, which is R sub y, over hypotenuse, which is R. Are you seeing this now? So if I cross multiply, I will have R sine theta to equal R sub y. Are you seeing this now? And let's call this one equation star. So if I want to look for the horizontal axis, it's become what? K, adjacent. Cos theta equal adjacent R sub x over what? R. So if I cross multiply here, I have what? R cos theta to equal R sub x, and that is our equation star. That's the second equation. Do you understand that now? So this is how to find the resolution of a vector. So the vertical component of this is equivalent to the vector sine of its angle, and then the horizontal component will be the vector cos of its angle. So that can now make us go directly to what? To that of a resultant of more than two vectors. Okay? Now that we have understand resolution now, so let me write it somewhere. Let's write it somewhere. Vertical components and the horizontal component. So our vertical component is r sine theta, and our horizontal component is r cos theta. Now, let's say we are given four vectors that makes an angle with the horizontal. Let's say this is vector f1 and is making an angle theta 1, and this is vector f2 and is making an angle theta 2, and this is vector f3 and is making an angle theta 3, and this is vector f4 and is making an angle theta 4. Are you getting this now? So if I want to find the resultant of all these vectors, so all I need to do first is to resolute each vectors. When I resolute each vector, I can now find their resultant. Am I making sense now? So how do we go about that? Just draw your table like this. So this place will be for the vertical component, and this column will be for the horizontal component. So how do I mean? For f1, the vertical component will be f1 sine theta 1. Are you getting this now? For the horizontal component will now be what? f1 cos theta 1. Now, this is positive and this is positive because the vertical component is pointing upward. Are you seeing it now? And the horizontal component also points to the right hand side. That's why this is positive and this one is also what? Positive. Then for f2, the vertical component will be what? f2 sine theta 2. And the horizontal component will be what? Negative f2 cos theta 2. Why? Because the vertical component is towards the positive axis of y. That is why it's positive. Then its horizontal component is towards the left hand side. That is why it's what? Negative. Then for f3, it will be f3 sine theta 3, and negative f3 sine theta 3, and this one will be what? Negative f3 cos theta 3. Why is it negative? The horizontal component is towards the left hand side, and the vertical component is the downward part, which is the negative axis of what? Y. So for the last one, which is f4, you have negative f4 sine theta 4. Are you seeing this now? Then you have what? Positive f4 cos theta 4. Why is this one negative? This one is negative because the vertical axis of f4 is towards the negative axis of y, and its horizontal component is towards the right hand side, which is the positive of x. That's why the horizontal is positive. Am I making sense now? So what do you do next? What you do next is to sum up the whole of the vertical components. So that will become summation of f of y, that is the addition of the forces of the vertical component, and that will become what? f1 sine theta 1 plus f2 sine theta 2 plus negative f3 sine theta 3. Are you getting it now? Plus negative f4 sine theta 4. That is the summation of the vertical component. Then summation of the horizontal component will be f1 cos theta 1 plus negative f2 cos theta 2 plus negative f3 cos theta 3 plus f4 cos theta 4. Do you get this now? Okay, correct. Absolutely. Now, there is a question that now arises here. And what's the question? The question is that if examiners say determine the resultant along the vertical component, what does that mean? What it means is that you should find the summation of the all forces on the vertical axis. If they say find the resultant along the horizontal component, it means find the whole of the summation of the forces along the horizontal component. But if they say find the resultant of the whole vector, so how do you go about that? That is very simple, and that's why we are here. So, for the whole of the vector, you now say, draw a right angle triangle just like this. Then, the resultant is this. So, this horizontal component, the resultant that you have here, which is summation of f of x, you put it here. And the resultant that you have here, which is summation of what? F of y. So, you have here to be your theta. Then you can now use Pythagoras what? Theorem. You therefore have what? R squared equal summation of f of x squared plus summation of f of y squared. Are you seeing this now? So if that should be the case, R equal the square root of summation of f of x squared plus summation of f of y squared. So whatever result you have there, that is your resultant for the four vectors. Is that it now? Okay? I think I should adjust this a bit. Okay. I think it's fine now. Huh? So, if this should be the case now, I think we can move on now and we'll look into the next one, which is when we are having two vectors that are inclined at an angle but not 90 degrees. Two vectors that are inclined at an angle but not 90 degrees. Now let's see that. Okay? And for us to be able to look into that, then we have to consider what we refer to as parallelogram law of vector. Okay. Now the question is, what is parallelogram law of vector? Parallelogram law of vector states that given two vectors u and v that are moving simultaneously, they can both be represented in magnitude and direction by the adjacent sides of the parallelogram, and their resultants can be represented in magnitude and direction by the diagonal line of the parallelogram drawn from a point. So what does that mean? If I have two vectors u and v that are moving simultaneously, so if I have something like this, so I have something like this. So this is u and this is what? V. And this is just a parallelogram. So if here is v, here will also be v, and here will be what? U. Are you seeing this now? So this is the angle of inclination. Their resultant is represented in magnitude and direction by the diagonal line. Are you seeing this now? So we want to determine the value of R. Already, we know the value of V and we know the value of what? U. Are you getting this now? So by extension, if I extend this line like this angle here is going to be theta because it's said to be corresponding to this one. Are you getting this now? And for me to get the value of this one, since this one is adjacent to this place, an adjacent angle, they are sum up to be what? 180 degrees. Therefore, this one will be 180 minus theta. Are you seeing that now? So this one is R now. If that should be the case, I can find the value of R using what? The cosine rule. So that will be R squared equal U squared plus V squared, then minus 2UV cos 180 minus theta. I see this now. So R squared, okay, before I go there, let me tell you something. Note that cos 180 minus theta will fall in the second quadrant. Are you getting this now? So because it falls in the second quadrant and cos is negative in the second quadrant, isn't it? Therefore, you are having that cos 180 minus theta is negative cos theta. So r square equal u square plus v square plus 2uv cos theta. Have you seen that now? So r, which is the resultant, is now the square root of u square plus v square plus 2uv cos theta. Have you seen that now? So that is how to determine the resultant. Then how do we then determine the direction? For us to determine the direction, we have what? We have to look for, let me consider this to be A, B, C, and D. I see this now. So if I extend this line down like this one will form an angle 90 here. And for me to get the vertical component of this, since this is u, which is forming hypotenuse, and this is angle theta, this one will become u sine theta. If I resolute what? U. I've explained that before. And from here to this place, let me call here E. From here to this place, will become what? U cos theta. Can you get that now? So, we can now find the value. Let's say the angle, that is the direction, is beta. So for us to get the value for beta, we say what? The tangent of beta is opposite, which is BE over adjacent. Abi? Adjacent, which is DC plus CE. Are you seeing this now? Okay? So, sorry, I want to make reference to that diagram now, but don't worry. So tangent of B will now become sine of theta, that is u sine theta, divided by DC, that is V, plus CE, that is u cos theta. So beta will now become the arctan of u sine theta divided by V plus u cos theta. So whatever result you have here is going to be the direction of the vector. Is that taken out? My camera is not well set. Okay. Okay, so I believe we get that now. So the last part of the class is the part of equilibrant. What is equilibrant? Equilibrant is a single vector that will balance the system of two or more vectors acting at a point. Are you getting this now? The system is a single vector that will balance the system of two or more vectors acting at a point. It has the same magnitude. Now, I want you to understand something. Equilibrants can only occur between three or more vectors. Are you getting this now? Why? It's because two vectors cannot make a closed system. You can make reference to my video on vector and scalar if you need more explanation on all these things I've been saying since there's nobody online to ask question on that. Okay, so or you ask question in the comment section. Anyone, I will always respond to you. Is that taken out? Fine. So three or more vector, that's when we have equilibrant. And how do we calculate for equilibrant? The same way you calculate for resultant is the same way you calculate for equilibrant, because they both have the same magnitude but opposite in direction. Is that taken out? So that is how we deal with equilibrium. So if your resultant is 5 Newton south, then your equilibrium will be what? Will be 5 Newton north. If your resultant is 5 Newton, then south 53 degree east, then the reverse will be the case. It will be what? 5 Newton north 53 degree west for equilibrium. They are equal in magnitude but opposite in direction. So that's that about what? About vector and scalar. So we're able to cover 2 topics today. By His grace, in our next class, we'll continue from where we stopped. And if you know you're going to prefer past question to this kind of a class, let me know in the comment section so that we'll be treating past question in place of this. Anyone, I'm open for your suggestion. Is that taken up? So without any further ado, I really appreciate you all, and I would like us to call it a day for this class. Thank you guys so much. I really appreciate you all. Thanks for coming.